Chapter 1. How AI actually works. Most people plateau after learning basic prompts. They get decent results and stop there. They type something in, hope for good results, and get frustrated when outputs are inconsistent. When things go wrong, they guess randomly at fixes. When a new tool launches, they start from scratch. They're missing the fundamental insight that changes everything. This chapter is for people who want excellent results, the kind that makes colleagues ask what you're doing differently. Once you understand what AI does, everything else makes sense. When outputs are wrong, you'll know why. When the results are excellent, you'll understand what worked. No technical background required, just clear thinking about what's really happening when you type a prompt and hit enter. The technology behind the tools. I mentioned LLMs, large language models, in the introduction. Now let's unpack what that means, because the architecture explains why these tools behave the way they do. Large describes the scale. These systems were trained on enormous data sets, with billions of documents drawn from much of the digitized internet, along with books, articles, code repositories. This isn't marketing, it's a technical requirement. The patterns these models learned emerged only at that scale. With smaller training sets, early systems could barely string sentences together. Language defines the domain. These models work with text. They take text as input and produce text as output. More recent versions can process images or generate audio, but the foundation is simple: words, sentences, paragraphs, documents. Model is the word most people gloss over, and it's the most important. An LLM isn't a database. It doesn't store facts and retrieve them when you ask. It's a statistical model, a mathematical representation of patterns found in its training data. Think about what that means. The model learned that certain words tend to follow other words. It learned what professional emails look like, how arguments are typically structured, what code syntax follows what patterns. It learned the shape of language without understanding what language means. This is why I keep emphasizing: AI predicts, it doesn't know. The model in large language model is a pattern matching system of extraordinary sophistication. But pattern matching is not comprehension. Fluent output is not factual accuracy. Confidence in tone is not correctness in substance. When you interact with ChatGPT, Claude, Gemini, or any similar tool, you're working with an LLM wrapped in a user interface. The interface makes it accessible. The LLM does the prediction work. Understanding this architecture helps you use these tools effectively and explains why the techniques in this book work. Now, let's look at exactly what the prediction process involves. The prediction engine. Here's what AI does. It predicts the next word. That's it. Everything else follows from this. Think about typing on your phone. When you type the capital of France, your phone might suggest is. Click on it, and Paris appears next. You've used autocomplete for years without thinking about it. AI works the same way, just trained on most of the internet instead of your text messages. The scale is massive, but the principle is identical. Predict the next word based on patterns in training data. When you prompt, write a professional email declining a meeting, the AI doesn't understand meetings or professionalism. It predicts what words typically follow that instruction based on thousands of similar examples it saw during training. This explains both AI's power and its failures. It's remarkably good at predicting likely word sequences. But predicting likely words is not the same as knowing true facts. AI is fast. You are right. I mentioned the competitor analysis mistake in the introduction. That experience established my verification protocol. Every factual claim requires verification. Every statistic needs a source. First draft, not final answer, always. Understanding the prediction engine changes how you prompt. You're not asking AI to know something. You're creating the conditions for it to predict useful words. The clearer your setup, the better its predictions. Clear in, clear out. Vague in, vague out. That's the foundation of the briefing method you'll learn in Chapter 3. But first, you need to understand where AI's predictions come from. The training reality. AI learned patterns from text, not truth from reality. This distinction matters more than most people realize. When people say AI was trained on the internet, here's what happened. The model analyzed billions of documents, websites, books, articles, forums, social media posts, looking for patterns in how words appear together. It learned that Paris typically follows capital of France. It learned that professional emails use certain phrases. It learned what product descriptions sound like. But the internet isn't the truth. It's whatever people wrote. That includes accurate information, outdated claims, popular misconceptions, and deliberate misinformation. All of it went into the training data. All of it shaped the patterns AI learned. This has 3 practical implications you need to remember. First, AI reflects biases and gaps in its training data. If the training data overrepresented certain viewpoints or underrepresented others, those patterns show up in outputs. You'll see this in job descriptions, content recommendations, even seemingly neutral summaries. Second, AI has a knowledge cutoff. The models were trained on data up to a certain date, usually several months before release. They don't know what happened after that. Ask about last month's election results or this quarter's stock prices, and AI will either admit it doesn't know, or worse, make something up that sounds plausible. Third, AI doesn't know your context. It never saw your company's internal processes, your industry's specific terminology, your team's current projects, or your client's preferences. Unless you tell it these things explicitly, it predicts based on generic patterns. The training reality means you're always filling in gaps. Every prompt needs context. Every output needs verification. Every claim needs checking against what you know to be true. Think of AI as a new hire who read everything ever published, but never worked a day at your company. Smart, well-read, absolutely clueless about your actual situation. That's the mental model. We'll build on it throughout the book. The capability map. AI has specific strengths and weaknesses that don't change across tools. Knowing this map helps you choose the right tasks and recognize when you're better off doing it yourself. What AI genuinely excels at: pattern-based tasks. Things like emails, reports, notes, summaries, and templates follow set structures. If you could describe the format to someone, AI can produce it. Text transformation. If you are seeking a different way to convey your message, change the tone to fit your audience, restructuring information from paragraphs to bullets, reformatting documents, AI excels at these mechanical tasks. First draft generation. AI is great for drafting blog posts, social media content, product descriptions, project plans. From empty page to a first draft, AI accelerates this process significantly. Just remember the mantra: first draft, not final answer. Brainstorming and ideation. Need 10 variations of a headline? 5 approaches to a presentation opening? 3 ways to structure a proposal? AI generates options quickly. You pick what works. Information organization. AI excels at sorting, categorizing, and structuring scattered information. Give it messy meeting notes and get organized action items. Hand it a transcript and receive a structured summary. What AI consistently struggles with: current information. Unless you provide it, AI doesn't know recent events, latest data, or real-time information. LLM on its own can't check the weather, look up today's stock prices, or tell you who won yesterday's game without access to current sources. Precise math and logic. AI approximates rather than calculates. For complex equations, multi-step logic, or precise numerical reasoning, it makes mistakes. Always verify calculations independently. True creativity. AI remixes patterns it saw before. It doesn't invent genuinely novel concepts or make unexpected creative leaps, useful for variations and options, not for breakthrough innovation. Judgment and nuance. AI misses subtext, sarcasm, emotional undertones, and implied meanings. It can't weigh competing priorities or make ethical decisions. Context that's obvious to humans is invisible to AI. Your specific context. AI doesn't access your emails, files, or company systems. It doesn't remember past conversations unless they're in the current chat. Every interaction starts at 0 unless you provide context explicitly. The surprisingly bad. Some tasks seem perfect for AI but consistently fail. Knowing this saves frustration. Counting things. Ask AI to count words, letters, or occurrences of a phrase. Watch it guess wrong. The prediction mechanism doesn't count. It estimates based on visual length. Following multi-step procedures exactly. Complex workflows with many conditional steps trip AI up. It approximates the process rather than following it precisely. Maintaining consistency across long documents. The further into a document you go, the more AI drifts from initial instructions. You'll see tone shifts, forgotten constraints, or contradictory statements. The surprisingly good. Some tasks seem too complex for AI, but work remarkably well. Explaining complex topics simply. AI handles explain quantum computing like I'm 12, or describe our privacy policy in plain language better than most humans. It finds accessible analogies and clear structures. Generating structured data from unstructured input. Turn meeting rambles into action items, extract key dates from lengthy emails, or organize scattered notes into prioritized lists. AI excels at imposing structure on chaos. Adapting tone for different audiences. The same core message rewritten for executives, technical teams, or the general public. AI handles these transformations smoothly. You provide the facts, AI adjusts the delivery. This capability map becomes your decision framework. Does this task involve patterns AI knows? Does it require current information or precise logic? The answer tells you whether AI will help or frustrate you. The failure modes. Understanding how AI fails helps you prevent failures and catch them before they cause problems. These aren't occasional bugs. They're inherent in how prediction works. Hallucination, inventing information. AI invents facts, sources, quotes, and statistics. Not occasionally, but regularly. And it presents these inventions with perfect confidence. This happens because AI optimizes for plausible text, not verified truth. When you ask for a source or statistic, AI predicts what a credible citation would look like. Sometimes that prediction matches reality. Sometimes it creates something that sounds real but doesn't exist. In my consulting work, I see this pattern repeatedly. Someone uses an AI-generated statistic in a proposal, 73% of companies report ROI within 90 days, and the client asks for the source. There isn't one. The AI generated a plausible-sounding number because that's what statistics look like. High-risk areas for hallucination include citations and sources, statistics and data, recent events, technical specifications, legal or medical information, and quotes from specific people. Drift, gradually moving off course. Long outputs slowly drift from your original instructions. AI starts strong, following tone, format, and constraints. By the end, it's forgotten half of what you asked for. This happens because AI processes text in chunks. Earlier instructions have less influence on later predictions. The further you go, the more it relies on its own output rather than your prompt. The fix? Break long tasks into smaller pieces, generate one section, verify it matches requirements, and then move to the next. Don't ask for 2,000 words in one shot. Sycophancy, telling you what you want to hear. AI tends to agree with you. Present a position and ask for analysis, and AI often validates your view rather than challenging it. Ask whether your idea is good, and it usually says yes. This makes AI a terrible sounding board for important decisions. It won't push back. It won't highlight risks you missed. It optimizes for responses you'll like, not responses you need. When you need critical analysis, prompt for it explicitly. What are the key risks I haven't considered? Or argue against this approach. Even then, verify conclusions independently. Conflation, mixing up similar things. AI confuses similar concepts, people, or facts. Companies with similar names get merged. Dates from different events blend together. concepts that sound related get treated as interchangeable. This creates subtle errors that are hard to catch. The overall output looks right. The specific details are wrong. Always verify proper nouns, dates, and technical terms. Overconfidence, presenting uncertainty as certainty. AI states everything with equal confidence. Complete fabrications get the same authoritative tone as verified facts. There's no, "I'm not sure," or "this might be wrong." Every prediction sounds certain. This is maybe AI's most dangerous characteristic. Confident lies are convincing. They slip past your skepticism because they sound so sure. The tool doesn't care about your deadline. Pressure doesn't improve accuracy. Only better prompts and verification do. These failure modes aren't going away. They're fundamental to prediction-based systems. The solution isn't better AI, it's better human oversight. The model versus application distinction. Every AI tool has two parts. Understanding the difference helps you choose tools wisely and adapt when things change. The model is the engine. It's the underlying AI that does the prediction work, the thing that was trained on billions of documents and learned all those patterns. Different companies build different models. OpenAI created ChatGPT. Anthropic built Claude. Google developed Gemini. The application is the interface. It's what you see on your screen. The chat window, buttons, features. ChatGPT, Claude.ai, and Google's Gemini interface are applications. They wrap the model in a user interface and add features like conversation history, file uploads, or team sharing. Here's why this matters. The same model can feel different in different applications. Claude's model powers both the free Claude.ai chat interface and enterprise tools with strict security controls. Same prediction engine, very different user experience and data handling. When someone says ChatGPT is better than Claude, they're usually comparing applications, not models. Features like conversation search, collaboration tools, or integration with other software live in the application layer. The core AI capability lives in the model. This distinction helps you evaluate new tools. A company releases revolutionary AI-powered software, ignore the hype. Ask, what model does it use? How does the application layer add value beyond what the model provides? Often, new AI tools are just familiar models wrapped in specialized interfaces for specific industries. The law practice management tool uses GPT. The HR platform uses Claude. The marketing suite uses Gemini. The model's capabilities are the same. The application just targets your use case. The skills you build in this book apply across models and applications. The briefing method works whether you're using ChatGPT today or whatever launches next year. Learn the principles, not just the buttons. The tools will change. The skills won't. Decision framework. When to use AI. Not every task benefits from AI. Knowing when not to use it is as important as knowing how. The task assessment. Before using AI, consider these questions. Can I describe what good output looks like? If you can't explain the success criteria clearly, AI won't deliver it. Vague goals produce vague results. Is this pattern-based work? Emails, reports, summaries, outlines? Yes. Deep strategy, nuanced judgment, creative breakthroughs? No. Can I verify the output? If you can't check accuracy, don't use AI. Medical advice, legal interpretation, financial calculations, these require verification you might not be able to do. Am I willing to review and edit? If you need something immediately usable without review, AI isn't the answer. First draft, not final answer, always. The new hire test. Here's a simple heuristic. Would you delegate this task to a smart, capable new hire who knows nothing about your organization? If yes, AI might help. If no, you're better off doing it yourself. Draft a meeting recap? Yes. Negotiate a difficult client conversation? No. Reorganize messy notes into a structured outline? Yes. Decide which project to prioritize? No. Generate 5 options for a presentation opening? Yes. Choose which option to use? That's your call. This test captures the essence of the briefing method. AI is your capable but context-free new hire. You are the manager. You provide direction, context, and judgment. AI provides speed and pattern recognition. Together, you get work done faster, but you're always supervising. Red flag. Watch for these warning signs that signal, don't use AI for this. You can't explain what you need clearly. If your own thinking is fuzzy, AI won't clarify it. Do the thinking first, then use AI to execute. The task requires information you don't have. AI won't magically find it. You're just getting plausible sounding guesses. Mistakes would be expensive or embarrassing. Client contracts, published reports, financial filings, medical decisions, the verification burden might exceed the time saved. You're using AI because you're stuck, not because it's the right tool. Writer's block, decision paralysis, procrastination, these are human problems. AI doesn't solve them, it just displaces them. The best AI users aren't the ones who use it most. They're the ones who use it wisely. That means knowing when to walk away. What you've learned. You now understand the fundamental reality. AI predicts the next word based on patterns and training data. Everything else, the capabilities, the failures, the decision frameworks, follows from this core insight. You know what AI does well and where it fails. You understand why hallucinations happen and why verification isn't optional. You can distinguish between models and applications. You have a framework for deciding when AI helps versus when it wastes time. Most people never build this mental model. They try random prompts, get inconsistent results, and give up frustrated. You won't. You have the foundation that makes everything else work. The next chapter answers the questions everyone asks, but most resources skip. Does AI have memory? How does it learn? Why does it hallucinate? How much electricity does it use? Straight answers without jargon. Then, in Chapter 3, you'll learn the briefing method, the complete framework that turns this understanding into consistent, excellent results. That's where everything clicks.